Hello, in this video we're going to look at an introduction to Pythagoras' theorem. So our main goals are to be able to find the length of the hypotenuse and to find the length of the shorter side using Pythagoras. Okay, so this is Pythagoras' theorem. C squared equals A squared plus B squared. So it's for right angle triangles, which look like this. The C in Pythagoras means the hypotenuse. Okay, A and B are the shorter sides. So what is the hypotenuse? The hypotenuse is opposite the right angle triangle. So you can immediately label your diagrams like this. So that would be C, opposite the right angle, hypotenuse C, opposite the right angle, hypotenuse C. And the shorter sides are A and B in any order. Okay. So first one, find the value of x correct to 2 decimal places. So we've got a little process here. First step is to label the triangle. So we know that the hypotenuse is opposite the right angle. So we're going to label it C. And then our other sides are just going to be A and B. Okay, maybe I'll make the pen a little bit thicker. Just a little bit. Hopefully that's not too much. Oh, that's too much. Okay. Sorry. Okay. Next step, we're going to write the formula for Pythagoras. So if there's 3 side lengths involved, it's Pythagoras. So C squared equals A squared plus B squared. Then, next step, substitute. And then we'll simplify. So substitute the numbers. We have the hypotenuse, which is x. So I'm just writing it directly in place of C. A, which is 6. So 6 squared plus B squared. So 7 squared. You're just replacing the variables, those letters, with the numbers in the diagram. And so we've got substitute and simplify. Okay, so we've substituted, now we're at the simplify step. So what you can do, BIDMAS says indices need to be simplified before subtraction, before addition. Okay, so we're going to do 6 squared and 7 squared first, then we're going to add them. So 6 squared is 6 times 6, which is 36. 7 squared, 49. Okay, write the left-hand side as usual. And then 36 plus 49 is 85. But that's x squared. We want x on its own. So what do you think the opposite, if we can get x on its own, that's what we want. What's the opposite of squaring something? Okay, let's think about our opposite operations, which we use to undo terms in algebra, okay? What's the opposite of add? It's subtract. What's the opposite of multiply? It's divide. What's the opposite of square? Square root. So what we're going to do is we're going to square root both sides of the equation. And that's going to cancel the square. Let me get that color back. Okay. Not that one. So we're going to be left with x, and they want our answer correct to 2 decimal places. So I'm going to put root 85 in my calculator, and that is 9.2195, but to 2 decimal places means we're looking at this, and that says we round up. That digit says we round up to 9.22. And yeah, I forgot to follow a process there. So units and decimal places is what you check at the end, but there's no units here. Could just write units if you like, but that's fine. Next one, find the value of x correct to 2 decimal places. So we've got this process to follow. Okay, we're going to label our triangle as step 1. So the hypotenuse. What do you think the hypotenuse C is in this triangle? Have a look. The hypotenuse is opposite the right angle. So I always just label it first. So that's C. and the other sides are A and B. Then we write our formula. C squared equals A squared plus B squared. We substitute the numbers. So C squared, well, our hypotenuse is X, and then we square that. 23 squared plus 8 squared. And now we're going to simplify. So BIDMAS says indices before addition. So do those indices first. 23 squared is 529 plus 8 squared, which is 64. But this, yeah, so let's simplify that. 529 plus 64 is that. But that's x squared. How can we get x on its own if it's being squared? We're going to square root both sides. Because opposite of square is square root. Okay. All right. And then you're left with, sorry, there is a loud car. Okay, x is root 593 and 24.351, and to 2 decimal places, that means we are keeping the number the same, 24.35. We're looking at that one. Okay, so that's what our value of x is, and just units is the units. Now, this one, find the value of x. What do you remember about this process? What was step 1? Okay, step 1, label the triangle. Hypotenuse. What do you reckon the hypotenuse C is in this triangle? Well, it's going to be opposite that right angle. So I'm going to make it C. And then the other sides are A and B. But do you notice anything different about this problem? Can you see that the units are different here? I know we didn't have any units before at all, but now we've got centimeters and millimeters. So at this step, if you can convert to consistent units, that will be very handy. Just get it out of the way and convert. Okay, so I'm going to choose to work in centimeters. So 460 millimeters to centimeters. So if you need to, go back and look at my video on converting between units of length. But to go from millimeters to centimeters, let's see. Millimeters to centimeters. I know the conversion factor is 10 millimeters in a centimeter. And what do we have? Which one is the horse unit out of millimeters and centimeters? It is this one. So we've got fly to horse, divide of course. So go back and watch that video if that didn't make sense. And so we're going to divide by 10, that's 46 centimeters. I'm going to put a box around that so I don't miss it when I'm substituting. Okay, actually I'll just write it up here. Just so I can see it. Okay, do you remember what the next step was? After we label that triangle, we're going to write the formula. C squared equals A squared plus B squared. Pythagoras theorem. Whoops. And we're going to have, okay, x squared equals 12 squared. Or we'll just make sure it's A. So 46 squared plus 12 squared. Make sure you substitute centimeters and centimeters or millimeters and millimeters, okay? Now, this one, simplifying the indices. Simplify again. 2260. But that's x squared. Remember, we want x, x on its own. What's the opposite of squaring something? Square root. So what you do to one side, do to the other. That cancels, and you've got x is root 2260. And that is 47.54 if we're going to 2 decimal places. Okay, and then units, we plugged in centimeters, so we should get out centimeters. And luckily they want our answer in centimeters too. So that's what you want to check as your last step is units and decimal places, okay? Okay. Now this bit, the exam will ask you to answer in either decimal places or as an exact value. Exact value just means don't reach for your calculator at the end, okay? Leave the square root sign in. So no, just really check what the question is asking you to answer in. Okay, let's go. Got our process there if we need it, but try to do it without it. So find the value. So maybe you want to pause this video and try this one. So find the value of x, answer as an exact value. Okay, first step, label your triangle. C is opposite the right angle. Okay. C squared equals A squared plus B squared. Substitute. So we're up to this step, substitute and simplify. Well, x squared is, we're just replacing the variables. 1 squared plus 7 squared. 1 plus 49. And then we want x on its own. So we have to undo that. Oh, actually, I'm getting ahead of myself. Let's simplify one more step further. Okay. And we want x on its own. It's being squared, so we need to do the opposite operation to both sides. That becomes x. And I nearly typed that in my calculator, but it's asking for your answer as an exact value. So you just leave it there. That's it. Don't tick your answer, but you just leave it with that square root sign is as an exact value, okay? Okay, nearly at the end of this skill. Find the length of x correct to 2 decimal places. So in this one, what do you notice is different compared to the previous problems? So let's just have a look through. Notice in the previous ones how our hypotenuse was the unknown. So now we've got a shorter side as the unknown. Okay, same process to follow. Label your triangle. Hypotenuse, C, opposite the right angle. And the shorter sides are A and B. Then write your formula. Step 2. Substitute and then simplify. Okay, just matching your diagram to this formula. Well, C this time, so don't be afraid to substitute on the left-hand side. So C this time is 5. We can actually substitute a value for it. A is x squared, plus B squared, so plus 4.4 squared. Now, substitute and simplify. We can simplify. 5 squared is 25. X squared, can't simplify that. 4.4 squared. 19.36. Okay. Now, we've got an extra step. We need to rearrange this. Because x squared is here. Well, x is here. It's got a squared happening to it. And it's got this plus 19.36 happening to it. So in order to undo this, you're going to move what's furthest away from x on this side. Do you think that the squared or the plus 19.36 is furthest? Okay, the plus 19.36 is furthest away. So we're going to choose to move that first, okay? What's the opposite of plussing 19.36 is taking 19.36. So and what we do to one side, we do to the other. Okay, you're doing great. Okay, 25 on this side, 25 take 19.36 is 5.64. And that, we did that so that it would cancel. And we got it a little bit simpler. And X squared is 5.64. We want X. So we're going to have to, what's the opposite of squaring? Square root. And what I do to one side, I do to the other. So that gets rid of that. I'm left with X. And it's saying correct to 2 decimal places. So root 5.64 in my calculator is 2.37. Okay. Now I believe this is the last question here. All right. Find the length of X in kilometers correct to 2 decimal places. Okay, so what have we got? We have a diagram here. It's a right angle triangle. And first step, label your diagram. Okay, we've got, oh, what am I doing? Hypotenuse is opposite the right angle. And then you've got your A and B are your shorter sides. Okay, write the formula. C squared is A squared plus B squared. C squared, so don't be afraid to substitute on the left side, is 9.7 squared. A, oh, and what I forgot, notice your units at the beginning. You can't substitute kilometers and meters in the same equation. So you've got to pick one. I'm going to work with meters, okay? So that's already there. This to meters, the conversion factor is 1,000 meters in a kilometer, and we've got horse to fly, multiply. So we're going to move that, and it should be 9,700. Just put zeros under those humps there. Okay, so that's important. Okay, we're going to substitute 9,700. And we got 390 squared plus X squared. Okay, now we want X on its own, and there's a few things happening to it. But actually, before that, we're going to simplify. 9,700 squared. I can come up with a number for that. It's a big one. 9,409,000. 390 squared. 1,521,000 plus X squared. Okay. So you always want to substitute and then simplify on each side as far as you can. And now we're rearranging. Okay, I'm looking at this and I'm thinking, how can I get X on its own? It's being squared and then this is being added to it. So I'm going to move what's furthest away first on this side. So it's not the squared, it's going to be this 152,100 is going to be moved first. So hang in there. We're going to, because it's being added, there's invisible plus sign there, you're going to subtract it on both sides. So to get rid of it, we're going to do that. Okay, now you're always looking to simplify with between each step, okay? Time to simplify. So I'm doing this number, which is 94,090,000, 94,090,000. So if the number's too big, separate it like 3 digits apart. Okay, so I'm doing that. Take 152,100. Is another big number. And we did that to get rid of it, okay? So just you can cross that out and we're left with X squared on this side. Now we know what we're doing. So X squared, how can I just get X on its own? Got to do the opposite of square. Square root. And we are left with, so keep that answer in your calculator. Root answer 9692.16 to 2 decimal places. And remember at the end, 2 things to check: units and decimal places. Units, we plugged in meters, so we should get out meters. So that, that is our answer there. Did I do that right? Yes. 9,692.16 meters. Okay. In the next video, we'll look at a little bit more of a different problem, but I think I've loaded you with enough information for now. So in the next video, we're going to look at a few applications in 2D, and we're going to draw a diagram from a word problem. So I will see you in that video.